everyone, myself I am Zeenath Jaha Begum from MLR Institute of Technology. So today we are going to discuss about the subject that is about the automata and compiler design. So I am going to start with the topic 1 from the unit 1. So in the last discussion we have discussed about the syllabus of the automata and compiler design. In that we discussed about the all five, whatever the 5 units are there. And also we discussed about the course outcomes of the subject, it is automata and compiler design. So now I'm going to start with the first topic of the unit 1, that is about the introduction to finite automata. Okay, so before discussing about the introduction to finite automata, so already in the last class we discussed about we have given with the introduction about the automata. So in the automata there are 4 types of automata, that is finite automata, push-down automata, linear bounded automata, and the last one, that is a Turing machine. So today we are going to discuss about the first automata, that is nothing but that is the finite automata. So what is the finite automata and what are the uses of that and how we are going to define in our subject we are going to see. So coming to the finite automata. So finite automata is nothing but it is a machine which is recognized as a pattern in terms of the input sequence, and it is going to be understood by a language that is nothing but that is known as the regular language in a computer science. Okay. So when we discuss about the finite automata here, generally a finite automata will work with the help of you can see here input as well as the states of the automata and the output. That means input, for example, I1, I2, I3, so on, I8, and different states of the automata. For example, it can be Q1, Q0, Q1, Q2, or it can be a capital A, capital B, capital C, so on. And finally, it is going to be fine with the output. The output can be in the form of like it can be O1, O2, so on, On. So this is the description like about the finite automata, how it is going to be defined. Now, what are the different features of the automata? As we discussed in the diagram that the features of the automata, finite automata, it will be like input, output, what are the states, set of states of the automata, then what are the state relationship, output relationship. That all those things are nothing but they are the features of the finite automata. Input, how the input is going to be defined. So input is going to be defined in terms of the symbols or in terms of the alphabets or in terms of the character which is provided by machine. Now coming to the output have the 2 things here, either it can accept or it can reject. So when it can be accepted, when your condition is satisfied, the result will be get as accepted or else it will be rejected. Now coming to the set of automata. That set of automata is nothing but what are the different conditions are there, or what are the different configurations will be available for the machines. Next, coming to the state relations. So here generally it provide what is the relation between the different state, that is known as the transition. The relation is nothing but that is known as the transition. And the last one, that is nothing but the output relation, that is based purely on the final state. That means the output decision is made only on the final state. Wherever your states end, that will be considered as the output, and also that will be considered as the final state. Now, so before we have to understand what is the input, what is the output, how the state transition has been done. So before understanding all those concepts, first we need to understand that what is the concept of the automata theory, okay, and what are the different things are there which is help to form the states, which generally help to form the transition from one state to the other state. So for that, there are 3 things which are important, that is string, alphabet, and languages. So first we discuss about the alphabet. What is the use of the alphabet? So you can see the definition here. What is the means of the alphabet? So alphabet is nothing but it is the finite set of symbols, and the alphabet is often denoted as sigma. If you can see here, uh, this is the symbol for that. So alphabet is generally denoted with a sigma. Okay, so how the alphabet is can be specified here when you see here. So alphabet, for example, in the alphabet A, B, C, so on, Z. So how the alphabet can be represented? The alphabet can be represented any English letter. That means it can be A, it can be B, it can be C, so on. Whatever the letters which has written in the capital A, that is that can be displayed in terms of the alphabet. In the same way, if you take B is equal to 0, 1, then B is an alphabet which is having two symbols, that is nothing but a 0 and a 1. So whatever the symbols which we are going to write, we have to write in terms of a 0 and a 1 only. Now coming to C is equal to ABC. That means given here ABC, so we have to write in terms of ABC only. We can't use D, we can't use E, we can't use F, because here itself it is given as C is equal to A, B, C. So by using that three symbols, we have to write the alphabet. Now in the same way, when we say D is equal to 0, 1, 2, 3, so on 9, that means the alphabet, the D can be written by using these numbers. So these are the some example to represent the alphabet. It is very simple. The alphabet is nothing but it is the set of symbol which can be represented with the symbol that is summation. So these are the some examples which are listed below. Now, what is the power of alphabet and how it is going to be represented? Yes, so as I have said that the alphabet is represented by the symbol summation or sigma, which can be also can be considered as if sigma is equal to 0. If there is no alphabet, that can be written as this symbol. This symbol is known as epsilon. Suppose in the alphabet, if you don't have anything, so that can be represented as that is nothing but epsilon. That means no matter when alphabet is summation. In other words, if the string has 0 length, if in the alphabet, if they have a 0 length, that can be represented as with the symbol that is known as epsilon. Now, just move on to the next one. Here, if summation or sigma is equal to A, B, C, then what it will be sigma 1? Sigma 1 is represented the same thing, A, B, C. That means a single combination, A, B, C. In the same way, if it is sigma square, that means what we are doing. Sigma square means what? Sigma square means what? Here we are multiplying sigma 1 into sigma 1. So whatever, that is nothing but like this, sigma into sigma. So here, what is the alphabet present in sigma? A, B, C. Multiplied by what? A, B, C. So what the combination we are getting? Double A, AB, AC, BA, BB, BC, CA, CB, CC. How many? 9 combinations, right? So this is nothing but a sigma square. That is nothing but 3 into 3. In the same way, if it is sigma cube, then what is that? That is nothing but 3 combinations, right? So it can be triple A, double A, double B, so on up to triple C. So on how many combinations? It would be a 27 combinations. So this is the nothing but this it is the thing which we can represent the alphabet. Either it is in, if it is a summation 0, that means the length of the alphabet is 0, simply we can represent as epsilon, or else if it is summation power 1, then we can simply return whatever the values are given in the alphabet. If it is summation 0, we'll multiply the two values. If it is 3, we multiply it into 3, summation into summation into summation. so on, we get the answer like this. That is nothing but that is the power of alphabet. Now, coming to the here, one more thing, continuation of that. If we uh, if you want to represent like this, summation star, that means it is continuation. It is a closure property. Summation star means what? That is summation of 0, or you can say union, summation of 1, summation of 2, so on, summation of 1, n. Because we don't know the length. If we don't know the length, so how it would be when we return for the alphabet 0, 1, it can be written like this, epsilon. Why we return the epsilon? Because the length of the alphabet can be 0 also. If it is 0, that is nothing but epsilon. So on 0, 1, 00, 01, so 1, 000, it will be 40, so on. So it is a unlimited, like it is not definite, it is indefinite. So that can be written in this way. That means set of non-empty string of an alphabet, summation is denoted as summation power plus. Summation power plus is nothing but the additional closure property, and to appropriate property it can be written like this. That means this is the additional property question and this is a closure property. So what is the difference means here? In the summation power plus and summation power star is nothing but, in a summation power plus, we does not include the value which is having null, the length of the alphabet is null. We don't include that. So we started from, that is summation 1, union summation 2, union summation 3, so on n. But coming to summation power star, that is a sigma power star, we include from 0, union 1, union 2, union, so on. So this is the actual difference between the positive closure and a multiple closure. That is known. So what is the difference here? Here, in the positive closure, we does not include the null set, the null property. But in the same way, here in the closure, that is a multiple closure, we include what? We include the 0 also, that is nothing but a null set also. Now, coming to the next thing here. In the last slides, we discuss about the alphabets and also we discuss about the power of set of the alphabets. Now, the second thing which we are going to discuss, that is about the string. What is a string? So string is nothing but it is the over an alphabet of a finite sequence of symbol from the alphabet. That means nothing but here it come from the alphabet and combine the sequence of the symbol which come from the alphabet, and it usually returned next to one another, and also it is separated by comma. That means whenever we write a string, that string is separated by the comma. So this is related to the alphabet. If we understand the alphabet, then we can able to understand the string. So we'll see here with the example. For example, summation 1 is given with the alphabet, that is 0, 1. And here we have to write in terms of a string. So how we are going to write the string? That means whatever the string here we are writing, the string should contain 0 and 1. It should not contain 2, it should not contain 3. So whatever the string you are writing, the string should contain 0 and 1. So you can write or else you can write 0, 1, you can write 1, 0, you can write 0, 0, 1, you can write 0, 1, 0, 1, so on, anything. So your string, whenever you are writing a string, the string should consist of 0, 1 because here alphabet is given as 0, 1. Now coming to the second one here. If summation 2 is given as A, B, C, so on, Z, then ABR, so we have taken with one example here, that is ABRA, CA, DA, BRA. So that is the string which contain from the alphabet, that is ABC, so on. Z. Okay, so that means you can write anything which comes under this alphabet. That is known as what? That is known as the string. Now, if W is a string, then the length of the W is written as bar W. If that means if W is the string, then if you want to write the length of the string, that can be written as by using this symbol, which is nothing but which is generally denote the number of symbols that contains. Now, what is the reverse of string? How you can write the reverse of string? Reverse of string can be written as W power R. So R is nothing but R is the reverse form. W, if W is a string, so reverse of the string will be nothing but W power R. It has to be written W power R. Now, coming to the operations here, what are the different operations are there for string? So here generally we say about some 2 to 3 operations, important operation. One is that is concatenation of string. So what is the concatenation of string? Concatenation of string is nothing but combining the two string and writing into one. That is, the concatenation of two string is the string formed by return the first followed by the second. So we'll see with one example here. For example, the concatenation of dog and house. So how you are going to write a dog and house when you combine it? Because dog is one string, house is one string. So when you want to combine that, that is nothing but dog house. Okay, this is a simple way. Okay, now when you write in terms of like we take some value x and y is equal to some x and y is equal to, we take 0 1 0 1, or y is I'll take some smaller value 0 1 0 and y is equal to 1 0 1. So if I want to write the concatenation of these two string, so concatenation of the two string, it is denoted by dot. That means x dot y. So dot is nothing but there is a symbol which is denoted for the concatenation. So it can be written as 0 1 0 1 0 1. This is the concatenation of the string. The same thing here, the example is given as x is given something, y is given something. So x dot y is nothing but combination of x and y. So it is written here. That is nothing but that is the concatenation of string. Okay. Now the next operation which we are going to see here, string reversal. Okay, string reversal. Reversal means what? Reverse of the string. So already we have discussed when we have find the definition of a string, that the reversing of a string is nothing but writing the string in a backward direction. That means if the string is given to L to R, left to right direction, reverse of the string is nothing but right to left direction. Okay, so how it is denoted? It is denoted by W power R. How it is denoted? It is denoted by W power R. W power R is nothing but reverse of the string. So for example here we have taken but small example here. Okay, that is ABCD. So if W is equal to ABCD, then W power R will be what? Reverse. It is from, if it is written left to right, we have to write it what? Right to left. D, C, B, A. That is the reverse of the string. Now coming to the next subtopic here, substring. What is a substring? The substring is nothing but it is a part of a string. It is a part of a string. So we'll see with some example here. If ABCD is a string, then possible substring will be what? It can be nothing. Nothing means what? Epsilon, or it can be a, it can be a B, it can be AB, it can be BC, or it can be CD, or it can be simple D, C, or it can be simple BCD, ABC, so on. So these are all are what? Substring for a given string. Okay. Now the next topic after alphabets, then string. The third topic is nothing but that is the languages or language. Now, this is very very important because without knowing the language, we can't draw any any automata, finite automata, whether it may be a DFA or NFA. So, before understanding what is the finite automata, what are the different types of finite automata, this is very important. That means how the language we understand, the language can be understandable if we know alphabet as well as the string. Now, what is the language? A language is what? It is a set of string. What is a language? Language is a set of string of which are chosen from sigma power star. Where what is a sigma? Sigma, what is that? Already we discussed. That is nothing but that is the alphabet, which is called a language. So this is the definition for a language. So what is a language? A set of string of all which are chosen from summation power star, where summation is nothing but it is the alphabet, which is known as the language. Okay, we'll see with one example, some of the examples here, how the languages can be how the languages can be seen. So the language of the whole string, for example, the language of all string consisting of n zeros followed by n ones. So we don't know exactly how many zeros are there and how many ones are there, right? So the question given it has n zeros followed by n ones. So what is that n zeros followed by n ones? So whenever you write 0, okay, and whenever you write 1, 0 should be followed by 1. 0 should be followed by 1. So you can't write 1 0. You have to write 0 1, 0 1 0, 1, so on. So however you write it, that is nothing but it has to be written as 0 should be followed by 1, not 1 followed by 0. If you see the example here, zeros are followed by, if you have written 1 0, 1 1 should be there. If you write 2 zeros, the 2 zeros should be followed by 2 ones. If you have written no zeros, that is nothing but no ones. That can be written as what? Epsilon. So here it is the language. So how the language is written for this here? How the, because condition also given what? N greater than or equal to 0. That means it can be 0 also. So when the language is 0, how it can be written? Epsilon. If the length of the string is 1, how it can be written? 0 1. If it is 2, 0 1 1. So on. Right? So on. Here it is given. So if 3 zeros are there, the 3 zeros should be followed by 3 ones. That is the first example. Now coming to the second example. A set of strings zeros and ones with an equal number of each. That means what? So there is no order that either we have to write 1 first or 0 first. There is no particular order for that. But the condition is given that if you have taken 2 zeros, 2 ones should be there. That means what? Equal number of zeros and equal number of ones should be there. So for example, if I have not taken any 0, nothing is there. That means no ones should be there. If no zeros, no ones, that can be written as what? Epsilon. Clear? If it is a 0, if it is a single 0, then it should be single 1. In the same way, 1 0. Because there is no particular order. They have simply specified that equal number of zeros and equal number of 1 should be there. So it can be 00 111, or it can be like this also, it can be like this also, or it can be or it can be 101100, anything. But the thing is that whenever you write the language, you just check it out whether equal number of zeros and ones are there. If I write like this, is this the string the consisting in that language? No. You can see here we are having 2 ones, but only 1 0. That means that is not satisfy for the following question. So this is not the one which we have to write. This is not correct. Now coming to the third one. The set of binary values whose value is prime. So prime numbers. You have to select the prime numbers here. Prime numbers means what? That is nothing but 2, 3, 5, 7, 11, so on. So these are the prime numbers. So you have to write the prime numbers. And what values you are taking? Binary values. What is binary values? 0 and 1. So by using this binary values input, you have to write the language that is nothing but a prime number. So this is nothing but 2, 3, 5, 7, 11, so on. Next one. If phi is an empty language, then the language over NP and any alphabet can be written as epsilon. That means epsilon is a language consisting only for what? For a empty string. Is also language over any alphabet. Now coming to here, what are the different operations on languages? These are very important because without this understanding we can't able to understand the language. So what are the different operations are there? The first one, union. Simple operation, union. Union means what? Nothing but whatever the sets, whatever the values present in the set, you are just combining and writing that. If you have some repeated value, you are ignoring that. Okay. So here we have taken two languages. So L generally stand for the language, that is L1 and L2. So language 1 and language 2. So consist of two languages over an alphabet. What is the symbol for the alphabet? That is nothing but that is the summation, or you can say sigma. Then union L1 and L2, which is denoted as. How it is going to be denoted as? L1 union L2. Now we'll take with one example and just check it out. So in L1 we are taking some values like 0, 0, 1, 0, 1, 1, and L2 the values are 0, 0, 1. So if you want to do the union, then how we are going to write 0, 0, 1, 0, 1, 1 and 0, 0, 1. So this is the answer for just simply combining and writing the answer. Now the next one, second one, intersection. Okay, that means whatever the similar values are there in the two sets, you have to write that. So if L1 and L2 are two languages over the alphabet, that is a sigma, then the intersection of L1 and L2, that is denoted as L1 intersection L2. So this is the symbol to denote the intersection. Now we'll see with the example here. We have taken with the example like L1 is equal to 0, 0, 1, 0, 1, 1 and L2 is equal to 0, 1. So what is the common value which we are having in the above two languages? That is 0, 1. So write the value that is 0, 1. Now coming to the third operation in the language, that is the complementation. So complementation, that is nothing but it is denoted by the symbol that is L power minus, which is the language which consisting of two strings that are not in the language over the alphabet. So we'll say with one example here. If in this alphabet it is given as a comma b, and we have taken some language that is L is equal to a, b, comma a. So how we are going to write the complementation, which it should not consist the alpha string which are there in the language. So L power minus is denoted as sigma power star minus L. That is, so when we take, so what are the remaining alphabets which are not there here? We can written as summation. Yes, sorry, epsilon. That is, generally first we write what is present in the sigma power star. That is epsilon, comma a, comma b, a, so on. Then minus L. What is L? L is nothing but a, b, double a. So we have to delete this from this. So when we delete that, then what is the answer we are getting? Epsilon, comma bb, comma ab, ba, so on. that is nothing but that is the complementation. Now coming to the fourth one here, concatenation. So concatenation is what already we discussed when we discussed about the string. So concatenation of the two languages is nothing but in which the strings are formed combining one string of L1 with the another string of L2. For example, this one. In other way, we can say that it is a form of the multiplication also. That is L1 dot L2, and concatenation of the string is denoted by what? It is denoted by dot. That is L1 dot L2. So here, next we'll see with the example. It is given as BC, BCC, CC, and L2 is equal to CC, triple C. So when we want to combine L1 dot L2, how we can write? We have to multiply this one. So 2, actually here it is 2, here it is 2. So when we write the operation, we'll get the answer like this. B triple C, then we get it as B 4 C's, B some 6 C's, then we get CCC, and so on. This is the answer when we do the concatenation. Now next one, fifth one, reversal. So reversal is nothing but it is reverse of the language, L power R. So if L is the language, so when we write reverse of the language, that is nothing but L power R. So how it is obtained? It is obtained by reversing the corresponding string which is present in the language. And it also what it can be written like this. L power R is equal to W power R slash where W belongs to the language. So we take with one example here, 0, 0, 1, 1, 0, 1, 1, 1. So when we write L power R, it will be 0. Then it will be 1, 1, 0 and 1, 1, 1, 0. The next one which we are going to see, that is about the clean closure. So clean closure is nothing but which is denoted by L power star is one thing, and second is also is L power plus. So already I have said you when we define about the string operation clean closure, that L power star is nothing but which consists of what? Which consists the null set also, and L power plus is nothing but it does not contain the null string. For example, if this is the language in L power star, so L power plus will be 0, 1, 1, 0, so on. So this is the major difference between L power star and L power plus. L power star is nothing but it can be simply say as just a closure, and L power plus is nothing but it is known as the positive closure, in that we don't have any null string, or the language which does not contain any null string, that is nothing but that is known as the positive closure. So these are the topics which we are going to see in the concept of the automata. That's all for the today's topic, where we discuss about the alphabets, we discuss about the string and the languages. So in the next class, next topic which we will be discussing about the types of automata, types of finite automata. Thank you.